So for this unit test case, because in our previous my stack using logs, we have already written unit test case for multi-threading operation as well as single-threaded operation. So I will just copy this most of the both of this unit tests here. So let's do it. So I will use this class name, alt enter Java class test. Okay. Yeah. Now let's to save some time. I will just copy this whatever we have here, and I will change it accordingly. So I'll just copy everything from here to here and paste it here. Now let's make changes here. First thing I need to change is the class that we are using. So it's my stack using SAS, and similarly here we are not having any bounded stack here, so it's just unbounded. So let's change this now. My stack using logs using SAS. Okay. So using SAS, using the single threaded. Rest everything should be same because this one is a single threaded operation, so it should be working. And the other one would be using two threads. So again, I will just do the simple changes here. SAS using multiple threads. Okay. So here, because we are it's not a bounded stack, right? So let me make some changes. Okay, the changes that I have made here is that I have, after we start this thread, because this is not a bounded stack as we have done in the previous logs test, where we are having a bounded stack of 5. So after pushing like 5 elements, it will block here and not push this F. And then we pop the top on the second thread, it will pop out E. But in this case, because it's not a bounded, so for thread 1, it will push all its items A, B, C, D, E, F. And then the stack would be looking like this, that we have got A, B, C, D, E, F, and top pointing to F. And that's why we have given some time of like sleep of 1 second, so that thread 1 completes here. Now when thread 2 comes, it will use mystack.pop, and then it will pop out the F element, which is the top of here, and the top will be pointing to here. So it would be deleted and top would be pointing here. Okay. So that's why the change here is that we are pointing out F here. In our previous scenario, it was the E which was popped because F was never pushed, right? And then we have got some space here, and after that only the F was inserted. But in this case, again, it would be only F, similar to like a single thread operation. It would be just taking out everything. And when this slash await done, I mean, once both the threads complete, so after that, our stack would be having E at the top. So it means that we are just when we peek and pop, it would be E. After that, we push G. And then after G is also gone, we would be having D at the top. That's what is represented here. So let me create a breakpoint here so that it's visible that what we just discussed. Before that, let me just run this first test case, which is the single thread operation. It should work. And using the SAS operation as well, because for single thread also it would be it's like nothing different than without using the SAS operation. It worked well. Now let's run for this multi-thread case. Not run it, but debug it. So I will just go here and debug it. Okay, so as we see here, my stack here, right? So max here, the top is pointing to E here. I discussed is E, and the next item is D. Next item is D, E, D, C, B, and A. And for A is null. So it's A, B, C, D, E. This is what we discussed, that after having these two threads done, A, B, C, D is done. The pop here would have like popped out F element, and that's why it should be E here. So let's run through it now. So if I do F8, so E has been peaked up, which is correct. And now we are popping out E. That's why the new value for top would be D now. And now we are pushing G. So now G is the top. and the next is D, and we just pop out again this, and then let me resume this because D is our peak. So it all worked well. So guys, this was all about my stack using SAS test. So again, this is using the compare and swap, and this is based on the tribal stack algorithm. I will give the reference in the description. So this was about concurrent stack using SAS operation. So guys, this concludes our problem 4, implement the stack in Java. We worked without using Java collections, using the stack node, using the linked list as we discussed. Then we used Java collection, which is Java util of stack, and then we used conditions and reentrant locks for implementing bounded concurrent stack using locks. And finally, we did concurrent stack using SAS operation. So in the next video, we will go to problem number 5, which is odd even printer using multithreading. So see you all in the next video.